No, aquí en invierno no, pero no.
¿Mande? Sí, pero creo que si se pueden pegar un poquito más el micrófono, lo escucho un poquito lejos.
You are now unmuted.
Okay, I'm sorry for the technical issues. So just let me find the slide that we're going to use in this session. And so before we start, I am going to answer the question that regarding the last session. So okay, so I think it's this one. So before we start, I am going to answer the question that we had to answer regarding the last session. I think that these are 3 or 4 questions that we're going to answer. And the first one has to do with the profile of the ones who are working with the small and medium enterprises. So one of the questions that we had is that sometimes we are analyzing some topics that, for instance, transport, and sometimes the scope is not just having income in the short run. And the first question regarding this was, is it necessary to have an impact evaluation when these are the things that you are considering? And the answer would be divided in 2 parts. One has to do with the type of things that you want to have an influence, and the other has to do with a more general point of view. And this has to do with if the decision to conduct an impact evaluation has to do with a technical aspect or a public policy. And the answer is related to both questions. So regarding the first one, because of the type of objectives in many of the programs that you might be involved, the example that I was mentioning was income. And this is a very common example in literature, and maybe this has to do with impacts on health and income. So that's why I like to use this type of examples. But of course, it depends on each program. It might be possible that what you want to analyze is if there was an increase in the volume in the sales volume, or an impact in the amount of businesses in a specific region. So this can be something way broader, depending on the type of programs and the type of questions. And it depends if this is something that is going to boost businesses, and what we want to understand and to analyze if this program is creating more jobs. So this is also related to the question if this impact evaluation is technical, or the answer is that it has to do with both things. This is a combination. When I started with the session, I was explaining how we can use an impact evaluation, and in that context, we need to consider if we are going to do something and how we are going to use the impact evaluation. We need to justify, for instance, the budget, or if I need to cancel the program, or if I am going to justify the program and if this program is working. So these are the kind of questions that we need to bear in mind when we are conducting an impact evaluation. Also, we need to analyze the funders. For instance, if this is the state, federal government, or local government, maybe in some countries, depending on the budget of the program, they have to conduct an impact evaluation. But sometimes when these programs are financed by the are funded by another type of international organization, one of the commitments is to conduct an impact evaluation. So this actually depends on the different circumstances, political circumstances, if it is worthy, because of course we're going to use results. And if this is mandatory, for instance, just because there is an institutional commitment. So why is it important to make this decision? Well, because impact evaluation is going to take time. We are going to have to allot specific budget, depending on the type of information. But so far, what we have explained is this type of random experiments. And of course, this is not going to be free. Even if we, for instance, let's imagine a program where we only have money for 50% of the population, and therefore we can use a random test to select people. Of course, this is going to be different because we're going to, for instance, have to invest or allot resources to select the people who are going to be. And we also need to have a baseline, for instance, to make comparisons between the individuals. And we need to guarantee that they were randomly selected. We need to follow up on the eligible individuals. Also, we need to have a follow-up survey. Of course, this is going to be expensive. Also, we need people who are individuals who will analyze this. We are going to hire a consultancy agency. So impact evaluations, of course, are expensive. So of course, not every single program is going to conduct an impact evaluation. We need to understand why we need an impact evaluation, if this is going to be useful, and if we just have, or for instance, if we just have to follow up on the indicators, if the what percentage of the beneficiaries received the benefits, what problems. This is something that we need to do in general, and of course, this is not going to be so expensive. So I really hope that it answers your questions. Of course, it depends on what you're working for. For instance, support to small and medium enterprises, and maybe you're going to need an impact evaluation, maybe a program that had to do with money transfers and trying to increase income in the target population. So maybe there you're not going to have an impact evaluation. This is going to depend on the need. Also thinking about the use of the impact evaluation. So the focus or the approach, and I really hope that this answers another question that is not so clear, but I really hope that I can answer your question, or if you want to restate your question. So what factors are important to conduct an impact evaluation? This is not very clear for me, but the objective of the sessions is not that I explain when and when not to conduct an impact evaluation, because of course this depends on the context of the policy and the reality of each program. And of course, you are the ones who know when to conduct an impact evaluation or not. I'm trying to explain how to conduct an impact evaluation once we know we need to have one. And I think that this has to do with the technical aspects. These are the factors. What we're going to be understanding throughout the other sessions is, given the characteristics of the data that I have, how can I use this information? What methodological focus I need to have a good impact evaluation. So this is what I am trying to explain. Of course, we already know that we have to make an impact evaluation. We already know that this is going to be useful. So how do I do this? And we have been talking about a specific case, experimental design, and we are going to keep developing this. Once we finish with this slide, we are going to talk about other methods. So this is the method that I was explaining before. This is like the gold standard, the ideal thing. If we could do something to evaluate an impact evaluation, then we would do this, because we do not need, and this is the example that I mentioned before. So basically, we just need a means difference. If everything was okay with the random selection and everything, then I can have the means regarding the control group and the treatment group, then minus this, and this would be the impact of the program. So from a technical point of view, this is very simple. That's why this is known as a gold standard. The other things that we're going to analyze require more technical assumptions, because I am not going to explain this right now, because we're going to see this later on. So I really hope that this answered your questions regarding the last session. So now, once I have solved your question, we were talking about the experiments, how we manage the information, what could go wrong, why this is not the only solution. I was talking about ethical issues, limited duration, people understanding that this is going to be specific. The experiment has to be specific and not copied. But for instance, I only applied this in a rural community. Other one was the treatment group, and the other one was a control group in a specific region. For instance, in a mountainous region in the country. So I know that the program is working, but because the context was very specific, I cannot use this and extrapolate the information to use this in other regions. So this is a risk involved. So sometimes we do something that is very specific, and then we end up not being able to apply this to other parts, because this is not just a pilot test. So we do not know if this program is going to work in other parts of the country. So besides, there are other problems that have to do with this experimental thing, that has to do with individuals who are going to change their behavior when they know that they are part of an experiment. So the first of this is known as the Young Henry effect in literature, and this has to do with a behavior in the control group, and when they realize that something is going on and that there is another group that is also being part of a treatment or group, and that there is something else happening. So this control group modifies the behavior, because they believe that this is what they are expecting, because they believe that maybe something is going to happen in terms of the external evaluation. So this is known as the Young Henry effect. This has to do with a story of a worker who was working in a railway in the States, and then he was just using physical strength to be able to build the railway, and then he realizes that there is someone else who's working with a machine and who has the necessary equipment to be able to do this in a faster way. So of course, he starts to work in to work more, even risking his own health. So that's the story. So when you realize that something else is going on, you realize that there is another group, therefore you change your behavior. And this is going to affect, because now the y variable that I wanted to measure is going to change because these individuals modified their behavior. And the other part has to do with the Hawthorne effect. And the ones who are in the treatment group modify their behavior not because of the treatment, but because they know that they're involved in a specific treatment. So the name has to do with an experiment done by modifying light intensity in factories. Maybe this is just a myth. So they changed light intensity in factories, and they realized that if they modified this, then workers would be working more. And in other places, what they did is that they changed the light intensity, and then they realized that also workers started to work more. And then this was a problem because, okay, what happens if we modified this? And at the end, what was happening is that workers realized that someone was observing them, and that then they realized that the behavior was changing. So this was not related to treatment or light. It was related to individuals knowing that someone was observing them. And then, of course, people are start to work more when they realize that their boss is observing them. And then this can happen when we have a random experiment. They already know that they are receiving something, for instance, a microcredit, and the other group, maybe they know each other, for instance, a neighbor or someone who did not receive the microcredit. And then these individuals are going to start asking questions, but someone received the program and the other one did not. And then they are expecting something to happen in the behavior, and then they change their behavior, not because of the microcredit, but because they know that they are being observed. So these are weaknesses that we need to control if we are going to have a real experiment. So of course this is not going to be easy. In theory it is really easy to have a random selection, but in practice we're going to face a lot of problems, and we need to be sure not to have them. Something a bit more complex that has to do not only with conducting the experiment in a good way or not, but this has to do with what we are doing, and the programs are known as general equilibrium programs. For instance, changing relative prices, changing salaries and wages, changing the different prices, sale prices. This modifies the economic relations, not of a small population, but also of a whole country. One of the traditional examples are, for instance, treaties or the NAFTA that is actually going to change a lot in a country. And this sort of things, we cannot select them in a random way. I cannot select in a random way the effects of the relative prices and the salaries, because I cannot control this. This is not going to affect only one group and the other one not. So this kind of things cannot be randomized. And besides, we also have policies that cannot be randomly assigned. For instance, we do not evaluate only positive effects. Also, we evaluate negative effects. For instance, whether the impact of a hurricane or an earthquake or a drought. So this sort of events, we need to do this to be able to understand the public or the measures that need to be implemented, and also how much money has to be allotted. So I think it is very, very obvious to see that this cannot be randomized. I cannot only say that the hurricane is going to affect one part and the other not, or only, for instance, considering droughts. These things cannot be randomized. Maybe we are interested in a program, in a government program, for instance, that has to do with remittances. For instance, if individuals only use these remittances for a certain activity per each dollar invested, then the federal government is going to invest a dollar. So this is a sort of way to have a match between money and between the dollars invested. And of course, this cannot be randomized because I cannot randomize immigration and remittances. I cannot say someone, okay, you are going to go to live in the States and you're going to stay here, and you that you are in the States, you're going to send money for your children and your parents. So no, this cannot be randomized. So what do I mean by this? Well, this can be either problems that we have to solve, ethical limitations, and that you cannot have an experimental approach because the government doesn't want to do things in this way of selecting people. So maybe this is going to be very complicated, limited duration, for instance, and then the characteristics. Everyone is selected in the program, so I cannot just favor some individuals. So what happens when this doesn't work? What we say is that we have to move beyond experiments. So the first way is to conduct experiments. If this doesn't work in this way, maybe the program is already implemented and we never thought about an experimental strategy because the program is already being conducted, or maybe the program doesn't exist anymore. So we have to do something else. And some of the things that we have to do is, for instance, linear regression. Then we're going to have instrumental variables, the fixed effects and differences on differences, matching, and simulation. So this is the idea of what we're going to see in this session and the following sessions next week. To be able to understand this logic, for instance, if you have to conduct an impact evaluation, you need to be able to have enough information. Of course, there are more technical aspects regarding this, but what we're going to talk is I am going to give you a general idea of the basic information that is needed for each method, basic intuition, and how to interpret the results. So at the end of the day, for instance, if you do have to conduct an impact evaluation with the information that you already have, you can conduct this, or maybe you need more information. And if you're going to conduct one in the future, maybe you can make a random selection. So I am going to provide the necessary tools so that you can understand the different methods to conduct an impact evaluation. So the first one in econometrics has to do with a linear regression or ordinary least squares. So this is something that is going to help us that has to do with intuition. And the first is that, for instance, if we use random selection or this can be done in a more sophisticated way with a linear regression model. And the other reason is that this is the basis that is going to help us to understand the intuition regarding the other experimental models. And with this, I mean these models. If we understand linear regression, we are going to understand fixed effects and simulation and matching. So I think that it is worthy to talk about intuition. What is a basic regression? Maybe you have already seen this in an econometrics. What I want to do is not providing a lot of information on the technical aspect. I would like to explain this. Maybe we are going to include technical terms. But the objective of this session has to do with intuition. And I really hope that you can have a better understanding of impact evaluation. Not It is not necessary that you have the technical aspect, that you understand the technical aspect, because of course this requires more sessions and econometrics sessions. So when we are conducting an impact evaluation, of course this is expensive, because generally you have someone who has enough expertise regarding this matter, or the one. But the main idea is that you can understand terminology, and that you can understand what type of evaluation you can conduct, even if you're not going to do this alone by yourself. So what is a simple regression, and how does this work? In a simple regression, this actually follows the same logic. What we want to do is to explain or talk about the relationship between an x variable and a y variable. But this we are doing this in a more formal way. So I would like to say what is the effect of x on y, and if we are and or the effect on on the variable of interest. What is the effect, for instance, on a money transfer? The effect of a money transfer on children's performance, or the effect of a microcredit on income of rural houses, or the probability of a woman in a market. So I need to understand this and the causal effect. So the first thing that we need to do is to write a model that we think can actually represent reality in a good way. And this model is what we have here. This is a simple regression model. And what we are assuming is that this is a valid model for the population. I would like to say something, for instance, regarding rural communities in the country. So I would like to say, what is the effect of the microcredit program on rural houses in a specific country? So I start with this regression. I want to analyze the income variable and the effect of the microcredit on that specific variable. So this is a linear regression like the one we have on the slide. So the x variable is the independent variable, or in this context, the response variable, and the y variable is another one, and the x variable is the control variable or the explanatory variable. Of course, we know that this is not just only a variable, and maybe this is not going just to be a linear regression model. Maybe this is going to be more complex. But the y part that we cannot explain with x, or the income part that we cannot explain just because someone does or doesn't have a microcredit, can be explained by other factors. And in this model, which is very simple, that only has one variable, which is x, the other things that we are going to explain have to do with the error. So in this equation, what we have is these three main components: the variable that I want to explain, the variable of interest or the explanatory variable, and the error. So the error is going to be the additional factors that affect y. So if we analyze this equation, this beta 2 coefficient is very interesting, because from a mathematical point of view, if we analyze this variable that we have on the slide, this explains the changes on y when x changes. So this is the question: how is the income going to change when there is a change in the x variable? So maybe has to do. So this is going to explain how the income changes if I have a microcredit or not. So what I want to do is to estimate this variable, because this is going to provide information on how the health changes, for instance, when someone receives a money transfer. So of course, this is going to be like a mathematical expression. If I know the information in x and y, then I am going to try to relate both variables. And what we are doing here, I am going to give you some examples, but visually we're going to have a name and a last name for the equations. So imagine that you ask, what is the effect of fertilizers on corn production? So I want to know if how much the amount of corn kilograms is going to increase. So this can be seen as a relationship like this. So beta 2 is going to explain how much corn is going to increase if the fertilizer is increased. But this can be also something different. The relationship between profitability in a company. So the effect of this on the people who work there. So this variable is going to say, okay, the benefits, what happens with the monthly payment of the general directors. So if I have this relationship between two variables, always from a causal point of view. So what we have here is to be able to see that what's the effect of x on y. We need to have some assumptions, and this assumption is very simple. The first one is, for instance, if I have the means regarding the errors would be equal to 0. And what does this mean? Well, for some individuals, I am going to measure the relationship. But if I have the average, then this is going to be equal to 0. I am not having a bias. In some individuals, I am increasing the number or decreasing the number, but maybe X is not explaining what should be explained. And at the end, I can measure both effects. So the most complicated assumption, and we are going to talk about this later on with more intuition, but the most important assumption is that there is no relationship between the x variable and the error. So this is the first part of this assumption. And of course, if the expected value of u is equal to 0, then everything is equal to 0. But the important assumption is the one that we have here. The expected value of u on x is equal to the expected value of u. So what does this mean? Well, what this wants to explain is that if I already know x, this is not going to provide enough information regarding the error. So from another point of view, the x variable or the microcredit, even if I do not have this microcredit, this is not related to the error. So we're going to I am going to explain this later on. When can it be possible that the error and the x are related? So the initial assumption is that there is no relationship between microcredit and the error, between the x and the microcredit, and the money transfer and the error. So later on, we're going to see what happens and why this error can happen. But if we have this error, what we can say is that if I have the expected value in this equation, the one that we have in the slide, this equation that I am showing in the 30s, in slide 36, this is equal to the effect that I want to measure, the effect that I want to measure regarding x plus the error. So if I am thinking from a statistical point of view, this is not a very simple relationship. I am going to observe a lot of individuals, for instance, 1,000 houses, and then I want to understand how each one is behaving in average. I want to know in average what happens with the income of the house's income with a microcredit. So when we are working with averages and regarding the assumptions, this is just an average. This is just the expected value of this variable. And this is what we'll work on. For instance, if I have a databases and if I know the income of the individuals, then I will be able to know if the individuals received the conditional money transfer program. So for instance, I already know X and Y, and I want to know what's the expected value of Y given X. So this is this is going to help me to understand this equation. And why is it important to understand this? Well, because the error is no longer present, because we were assuming that error was equal to 0 and that the error and X were not related. So these assumptions are going to help us to obtain enough information that is going to help us to analyze this equation. We are not going to talk about the ordinary least squares model. That's not the objective. But if we have the previous assumptions, we can have some formulas that can help us to estimate the model. And how do we interpret this information? If I use information, for instance, regarding wage per hour and education, if I have information regarding the education of a specific individual, and also if I have information regarding the wage or income of an individual, I can have this for 526 people. So for them, I have information regarding the education level and the income. So under the assumptions that were previously made, then I can estimate an ordinary least square model or a simple or linear regression. And when I estimate this, then I have the numbers that we have in the slide. Instead of beta 1 and 2, now I have numbers because I already made this in SAS, R, or whatever. So how do I interpret this? What information is this going to provide? Well, exactly what I wanted to know. What is the effect of an additional year of education in the expected value? So if I increase education in 1 year, then the income per hour is going to increase by these numbers that we have in the slide. So of course, per each additional year of education, this is going to need an increase of 0.54 cents. So this is how we're going to interpret these results. So it is very important to mention that with these econometric methods and in general, when we were analyzing the means difference in a random selection, what we want to understand is the effect, not for each sample and not for every single individual, no, but in average. So of course I want to know the effect of the program, but in general, in average, not for a specific individual, but how much the income increases, for instance. So this is something very important that we need to take into account. We're talking about averages. So this is like the basic logic of the simple regression model. We are relating both variables, and then we are analyzing the error, and we are also using random selection. We are saying that there is an error, and how do I incorporate this to the model? Well, first a information sample, and also we need to have assumptions regarding this error. So regarding the simple model, we're also going to have a multiple regression. This is a way more interesting model. Why? Well, because I have more variables and not only one. I have every single variable is an explanatory variable. So here I have x4, x3, x2. So what do I get with this? Well, I can control many factors that can affect y. For instance, just a very simple effect. The model that we talked about before, the effect of education on income. So now I can say, well, maybe if I understand this in this way, what I am saying is that the main variable that affects income is education. Everything else is something that is more random. And of course, we know that this is not true. There are more variables that are going to have an effect on income. For instance, expertise. So if we have this multiple regression model, I can use this I can include this variable, for instance, expertise, and also sex is going to have an effect on income, age, and other things. So I am going to have a more complex model that is going to be controlled by more things. This is not just a variable against another. This includes a lot of variables. So regarding this example, we are saying that the previous one was the wrong model and the right one is this one. But what would have happened if I just considered this one? Well, this variable regarding expertise was included within the error, so I had an omitted variable in the error. This is a very important thing that we are going to cover later on. But the key point here is that we can also have a multiple regression scenario. I think that now I have a lot of variables and this is very consistent. I can be interested in one variable, but I am also including the other variables that are also very important. And at the end of these slides, I am going to talk about the impact evaluation regarding a multiple regression model. So we already talked about the simple model. Now we have a more complex model that has a lot of variables and not only one, not only education, but age, sex, gender, education, income. So the assumptions are the same one. For instance, let's assume that the error is not related to just one variable. So the important thing is that if this assumption is wrong, is right, if the error is not related to the other variables, then I can interpret the beta variable in causal terms. So what I am measuring is the effect of X on Y. This is not a correlation, but this is causal. And this is something that I am going to explain further on later on in next session. So the formula, for instance, if you already know this is the formula. Of course, this is not something that we're going to use because it's complicated. But if you already have a model like the one we have here with variables, then we can show that the way to estimate this is this one. This is an algebra model. I have the information regarding the variables, and then I can have this algebra operation. If you are not aware of this and if you do not know this, then do not worry. Maybe you have already seen something like this, but this is just a technical aspect of what we need to do or would do. So before we finish this first presentation or this first part, we need to understand the relationship between ordinary least squares and impact evaluation. And with the same terminology that we have been using, if we say that treatment is going to be known as W, is if I receive or not the treatment. So I can say that this is the regression that I want to use. For instance, I do care about the effect of the microcredit on income, on job opportunities. So this is what I am doing in a regression model. So what do I get by having this multiple model? Well, I can do this in a more controlled way. So I'm interested in the impact of the program. This T letter that we have in the slide, this is what I want to measure. If this is big or small, if microcredits are going to increase income by dollars, $40, $8,000. This is what I want to measure. But at the same time, I am saying that this is not the only thing that has an effect on income. Maybe gender, education, and other things are going to have an effect. So by doing this, I am isolating this effect. And if the assumptions are met, then this T letter is going to explain the effect. So I cannot say that the effect that I am trying to measure is treatment, but maybe this is due to education. No, because education was already included here. So maybe someone can say, okay, no, this has to do with gender. No, because I already have a variable included including gender. So these are the things that I am going to try to control. to be able to isolate the effects of the program. So of course, this is not going to be easy, and generally, even when this model includes controls, then we're going to start explaining more. So when the treatment is random, as we have seen so far, I can include this regression, and this regression is going to give the impact, and I am going to be able to understand the impact of the program. So this experimental method is a very, very useful, and this can be included in the impact evaluation. A linear regression doesn't need a lot of assumptions beyond the assumption that the error is not correlated to you. So this is an open question. What happens when the program was not random? Or what happens when we have an endogeneity problem? Everything was working so far, the assumptions were met, and a regression was able to solve this. So what happens when W is not random? Then we're going to solve this question later on in other sessions, also today. So this is the first presentation. We are going to use the second presentation, and then we're going to explain more.
You are now on mute.
Okay, so I am just going to change the presentation. So I think this is a good time to guarantee that we are understanding everything, and I want to highlight and to use a more visual logic before we talk about these assumptions and when they are not met. So to do this, I thought that this would be important to remember what we achieved with this impact evaluation, and also regarding the counterfactual, because at the end of the day, this is the main idea that you need to understand from this sessions. You need to understand the counterfactual. Why is it important? How do we use it? So I want to highlight this and to explain this in more detail. So let's suppose that we want to evaluate the impact of a policy. So in general terms, we can have a lot of variables of interest. So the first one is going to be Y, or variable of interest. And we can see, we're going to observe how this variable works. So throughout time, this is going to change. This is just an assumption. This is just a way to explain this in a visual way. Maybe we were following up on this variable in average. So I am observing this variable throughout the years, and I analyze how it is behaving. So let's suppose that we are including a treatment policy or program. And then I keep observing the same variable, the information included in the blue dots. So let's suppose that this increased. I want to analyze the impact of the program in a specific period of time after some years. So we start here and we end up here. So this is what I am currently observing. And we can have an error here because we could say, okay, what is the impact of the program? I do not know. Only with the information, the information that I have here, I cannot understand the impact of the program, because we are not talking about how the variable changed through time. Because I can say, okay, Y increased throughout time, or y increased. But what I cannot say with this program is that this increase is due to the program, because actually it can be due to a lot of things. So what do I have to understand to have to understand the impact of the program? Well, I need to consider the counterfactual. In this scenario, what is the counterfactual? Well, the counterfactual is what would have happened with these individuals without the program. So the blue information is the information that I am currently observing, or the information that I can obtain in the official statistics or in the databases. So this is just a construction. This is not this is the counterfactual idea. So how do I build or develop this counterfactual? Let's suppose that this is the real counterfactual. So if I already know this, then I can say that this is the impact of the program. Because if the program did not exist, then this group of houses or individuals, the variable of interest would be here in average. But because the program exists, they are here. And this difference is the effect of the program. So now let's analyze a second scenario. This is the same evolution regarding the same variable without the program. Then the program happens. We can observe that the variable is behaving in this way. So what would we think if we can say that this program is working because this program actually increased? But no, this is an error, because we do not know. Maybe the natural evolution of this variable, of this y variable, behaved in this way. So the counterfactual would be providing information, and it would be saying that if you wanted to improve the variable, the program did not work. Actually, the program is not useful, because the expected value of the variable without the program, and if we left them alone, then this would be here. But it is here because we have a program. So what I observed is this, and so the program had a negative impact. And if I do not consider the logic regarding the counterfactual, I cannot have an impact evaluation. If the only thing that I am observing, and we already talked about two scenarios, maybe there is a scenario where the counterfactual was low and the program had a positive effect, and there is another scenario where the counterfactual was supposed to follow another direction and the program had a negative impact. So what is the real counterfactual? We have to develop this. For instance, the example that I gave you before, Luisa, in two parallel scenarios, the grasshopper in the last session going to the right and to the left. No, actually he can only take one path. And a third example to emphasize the importance of impact evaluation. Maybe I am really convinced that this is a useful program, and then I do not need to measure this. So if I just observe this, then it is okay, because I know that this is due to the program. I do not need to evaluate this, but maybe income is behaving in a good way, or the percentage of the population beyond below poverty line. So in this case, this would be another thing, but income is increasing in the program, so I can say that this is the effect of the program. But I already know that the program is not going to damage income. So there are more complicated scenarios. Let's suppose that we have something like this. This was the y variable income in a specific population, for instance. So maybe the program is conducted, and what we observe is that income is decreasing. So we can have some problems here, because other because the program is not working, and actually it is not useful for income because the income is decreasing. So maybe people are doing worse than before. And this is because we do not know the counterfactual, and maybe this is a reality because of different circumstances, and maybe this is not the program, but at the same time maybe there is a negative effect that is currently affecting the income of the country. So the income is decreasing, and without the program, the income would have decreased way more. So the program is actually working. The program has a positive impact. Income without the program would have decreased way more. So I really hope that this is clear, that you're understanding this. If I only analyze the evolution and the behavior throughout time, I can either be surprised in this scenario, in the second scenario. So I can think that okay, maybe this is an amazing program, or maybe I can think that the program was a great idea and it's not working, so I need to get rid of the program. If I had an impact evaluation, or maybe I can include this counterfactual logic because I do not know the effect of the program, and in this case, income did decrease, but maybe it would have been worse without the program because otherwise income would have decreased way more. So this is what I wanted to explain, and that's why the impact evaluation is very, very important. Why? Well, because we are going to intertwine this. We already talked about the experimental method, and this it aims at developing a solid counterfactual. We also talked about regression assumptions. So we already talked about this and how to develop the counterfactual. So this is going to help me to understand what would have happened if the program did not exist. And this methodological challenge this is something that we're going to face if we are going to conduct an impact evaluation. So we need to have different assumptions to identify the causal effect. And this includes technical terms because in econometrics we say that we have an endogeneity problem. So we're going to define this word with technical terms and also to understand this in a better way. So what do we understand by endogeneity? Let's suppose that we have this regression, a multiple regression model. So I have a lot of variables. Maybe this is the program, so I want to analyze the effect of the program on Y and beta 2 and education, age, and so on and so forth. So we say that we have an endogeneity problem when one of these variables, one or more, is related to the error. The simple way, the variable the variable of interest is related to the error, and this is an endogeneity problem. So the regression model assumes that the x's are not related to the error. So when I am going to estimate a regression, I can say that this is the causal effect of x2 on y. So the assumption of this, if x2 is related to the error, then we say that there is an endogeneity problem. And why can this happen? Well, the most simple scenario is the one that we have as omitted variable. I am going to give you an example. So let's suppose that we have the same model. This is a different version where the x's are explained as a vector. So let's suppose that this is the exact same model that we had before, and then we add a q variable that we have here. So the right model is this one, the one that we have in the slide. And this q variable is not related to the error. But for instance, this omitted variable, which is q, is a variable that was not measured. So I cannot measure this model. The only thing that I can measure is this one that I have in the slide. So I have the x's and I do not have the q. So the q is included in the error that I cannot measure. So what I am trying to explain is that when this happens, we say that there is a correlation when we have an indigeneity problem. For instance, in the error, now we have this q variable. If this q is related to the x, then we have an indigeneity problem. Let me see if there is an example somewhere. Okay, let's analyze this. So let's suppose that we are following the same logic, and what I want to explain is the effect of education on income. But maybe there is a variable that I am not observing. This can either be motivation or expertise. So because I am not observing this variable is in the error, and this variable is this q. It is easy to say that this variable should be included here. We would expect that someone who is more motivated is going to have a higher income. Remember that I am trying to explain income. And that's why we should include motivation or skillful or skills. But maybe this is related to motivation and skills, and this is going to be, for instance, if only some individuals are motivated or are more skillful, and if they have more years of education, then there is a relation between these variables. So this assumption is, I was assuming before that the x and the error were not related, but now I am saying that given that there is a variable such as motivation or skills, then this is related to the x variable. So far we are explaining why the error can be related to a specific variable. For instance, expertise or skills can be related to education, and the same would happen if, for instance, if we analyze the impact logic. So let's suppose that I want to evaluate the effect of the program known as W, and maybe this program was not random. So if this treatment is related to an omitted variable, then we have an indigeneity problem. I really hope that you remember the example that I gave you on Tuesday regarding textbooks. There were some schools with textbooks and other schools that did not have textbooks, and I wanted to analyze the performance. So this was not the textbooks were not randomly assigned. So maybe I can control this regarding the income, the age, but I do not have information or this hypothesis that I was explaining. Maybe they are parents because the parents are really interested and involved with their kids. So given that they are very interested in their kids' performance, they are involved with their education. So if this happens, and if this is what, if I'm not observing the involvement variable and the education, then this variable is within the error, because this variable is going to have an effect on school performance, because of course the parents asked for the textbooks, and of course they are going to be more involved in their homework, and they're going to foster reading and everything else. So here I have this variable of the parents' involvement with their kids. So maybe this should be included in this equation. And because I do not have this, then this is in the error. But besides this variable explains why these schools have textbooks, well, because the parents asked for the textbooks and the government provided the textbooks. So this variables is not a random variable. And this is correlated to something that I am not seeing. So this is an example of this selection bias. having or not having textbooks is a self-selection problem. If I am talking about this regression, or if I can estimate this t, then I am going to have the number, but I cannot say if this is measuring the effect of w on y, the effect of textbooks on school performance. So what I have here is we have an endogeneity problem. In many cases, this is a problem of an omitted variable. The error is related to one of the variables. In this case, it is w. So maybe this is not that clear. And maybe there is an econometric problem, but why does it affect causality? So before we delve into it, in general, we're not going to be able to conduct an impact evaluation with a linear regression if the treatment was not randomly made. So if the treatment was not randomly made, then we're going to have a lot of omitted variables, because this is going to affect some of the variables of interest, and also the probability of some individuals receiving the treatment or the program or not. For instance, entrepreneurship, skill, motivation, and quality, amongst others. So here I have a selection bias where one or more of these characteristics explain the variable of interest, which is y, and also the participation in the program. So if the program is not random, and if this program is provide a microcredit for a specific household, then it is very likely that a very motivated individual will find out that there are some microcredits, and then he or she is going to ask the microcredit. And why? Well, because we have a variable that we are not observing. And at the same time, because he or she is very motivated, then this is going to work for him or her. And because I have the microcredit, because he or she has a microcredit, then I am not sure if I am measuring the effect of the microcredit, and maybe I am just taking into account that he is a very motivated individual. And there is another, for instance, someone who is not that skillful or motivated, then maybe he's going to have lower incomes. But this is not due to the microcredit. This is due to his specific personality, not because of the microcredit. So here we cannot talk about causality, and this is complicated because I cannot measure the impact. So this is the same logic. This is the same point, the counterfactual, where it was located without the program. Where would it be located without the program? So far, and we have been focusing on endogeneity. This has to do with an omitted variable, and we are going to have this in the impact evaluation. Of course, simultaneity also creates endogeneity problems and this is when we do not understand what comes first, the y variable or the x variable. So in economy, we have this, the offer and supply example. Well, both are defining this at the same time, but I cannot explain offer and supply. Or what happens first, the amount of policemen in a specific place, or crime. So maybe if there are a lot of violence acts, there are going to be more policemen. This is a simultaneous logic and relation, and this is also going to cause problems. But let's just keep with this logic, the omitted variable logic, and this has to do with selection, because there is something that is explaining why I have this program, or why is it going to be more likely that I am going to have the program and my neighbor is not going to receive the program. And then why do I have a better income, sorry. So this has to do with inconsistency in econometrics. But what we are really interested in this case is the problem. So let's suppose that we have this model where we have only one variable. So I would like to explain the effect of x on y. We're going to do this in this way because we're going to be able to analyze the assumptions and why is it important And I think that this indigeneity logic is very important because this is going to have an impact on causality. So far, if I was saying that x and the error are not related, technically we were saying that the correlation was equal to zero. And if the assumption is maintained, and if there is if I have this linear regression model, then this beta 2 is going to explain the causal effect of x on y. So if this program was designed in a random way, and if this program is working, then I can have this regression model, and I can say that this number that is going to be here, and the model that we already know, this is going to provide information on the impact of x on y. So if this doesn't happen, we can say that the ordinary least squares works. So if there is an omitted variable, then we're going to lose this property, this consistency or causality. And why? I want to say that x causes y, not only related. So the program is causing the effect that I am currently observing on y. And why is it so important? Well, this diagram that we have in the slide, this is the model. I only have one x, the one y, and the error. So the assumptions that I include in the model are included here. So what I am explaining is that there is a y variable that I want to explain. This y variable, I want to explain this in, and the variable that I want to control is x. So I say that x has an effect on y, and I am also saying that u affects y. So this is an expression of this model. So this y is explained by x and by u. And besides, we are assuming that these are not related. So that is the assumption, that is the model if you want to analyze this from that point of view. In this diagram, I think that it is easier to understand this. I want to explain y through x, and I am assuming that there is no relation. And then it happens that this is not met. Maybe I have an omitted variable, so I wanted to explain the effect of education on income, but maybe this model is not working because I have motivation, expertise, and that sort of variables. And motivation can actually affect income, but it can also have an impact on education. So it happens that my model is not the same as it was before. This assumption that I already made when x and y were not related, then this is not met. So why is it important? Well, it happens that when I analyze things in this way, this beta 2, and I'm really sorry that I'm going back to the same thing. So this beta 2 that we have here, I was saying that this is going to measure the causal effect of x on y, or the variable of interest, or the causal effect on income or education, only and only if the assumption was met. So in this scenario, beta 2 was providing this information, and now I am going to have the same mathematical formula to obtain this beta 2. And what I am observing is x and y, so I was trying to approximate or calculate this. But the problem that I have is that beta 2, and this is the one that I can calculate or estimate, I am not going to be able to know if this is the effect of x on y, or because this, I cannot see this arrow because I am not observing the error, but we know that there is an effect. What this is measuring is the effect of education and income, but maybe this is also measuring the effect of expertise on income through education. So of course, this is going to affect education, and through education, and education affects income. So this additional relationship, I cannot separate the effects, so I do not know what is being measured, if this is the effect of x on y or the effect of the omitted variable on y through x. So from another point of view, and regarding this impact evaluation example, if we are in a scenario in which some of the individuals were selected, if there is a characteristic that is not observed regarding the individuals that explains why they have the program. For instance, entrepreneurship. So the microcredit program that I want to analyze the effect of microcredit on income. So if this is going to have an impact on the household. So if the program was not random, if the people selected themselves and asked for the program, some of them insisted on having the microcredit. Maybe it was not that easy because maybe they had to travel to the city, they have to fill in forms. And yes, of course, most of the programs are complicated. So it is not that easy to be included in one of these programs. So if there is someone more motivated, and it is more likely that this person is going to receive the program, and that's why we have a relation. The ones who are more motivated are going to receive the program, and the ones who are not that motivated aren't going to receive the program. So maybe this program is related to this. And then the entrepreneurship variable is not observed because this cannot be defined. And besides, someone who maybe someone is going to have a better income because he is currently trying to improve all the time. So this is going to have a better income, and this increases the probability of having a program. So the only thing that I am currently observing in the simple model with two variables is the income of the individual, and if he received or not the program. I am not aware if he was motivated or not, because this I do not have this information. So this variable, I estimate this variable, I have an associated coefficient. And if I do not take the impact evaluation logic, if this can be compared, then I would make a mistake, because the effect that I am measuring is just the effect of the program. But what I am currently measuring is the effect of the program. Also, I am also measuring the effect in the income. So I really hope that you are understanding this, and I really want to convey the importance of an omitted variable, so I cannot talk about causality. If this is a correlation, this is a correlation, but I am not sure if what part is due to x on y, and then what is due to x on y through x. So this same logic in the counterfactual is a bit more complicated, but without the program, given that he is an entrepreneur, he's going to have a better income. What I want to do is to isolate the effect of the program. So this is the general logic. Someone is asking, for instance, how can we know that we have an omitted variable? I think that this has to do with how do we know if we have an omitted variable. And I think that it is very important to not only to understand the technical aspects, but also understanding the one who is trying to evaluate the program. And this has to do with intuition and also a model. And also it has to do a lot with intuition, because I really hope that these examples are really easy to understand and to follow. For instance, if I want to explain the effect of education or the effect of a microcredit on income, and if I am not controlling the other things that could happen, then I can have this logic. For instance, I can have an argument. Because this was not a random selection, then this is going to be very likely that the individuals who are included in the program are different from the ones who do not, yeah, who are not included in the program. So maybe this was not a random program. And there are some characteristics regarding the individuals, because these are characteristics that we cannot observe, and this will have an impact on the individuals. Of course, this can be either negative or positive things. I am going to observe age, education, and among other things. But there is something, for instance, if the individual asks himself for the program, then if this happens, and actually this happens in every single program, unless they are mandatory and everyone is involved in this, or if they are random, and I select the individuals, people are going to start asking for themselves. So of course it is going to be very hard that I can control every single variable. Almost always I am going to have a non-observed characteristic or an omitted variable that explains why some individuals are included in the program and others are not. So what I would like to add is that if the individuals were not randomly selected, then we are almost pretty sure that we are going to have a problem regarding omitted variables, because there is something that is explaining why someone has a program and someone is not included. And just let me check something. So this has to do with the logic, the error, the omitted variable. Of course, this is going to make a simple regression model more complicated. So what we would have to do is to either keep justifying and saying, okay, that's why I really love the experimental matter, because I was not the individual. Let's say that this is the key of the experimental part. I really hope that you understand this in a clear way, because the individual was not able to do something to decide to either be or not to be in the experimental part. So there are no omitted variables. We are not considering any characteristics. He didn't do anything to receive the treatment because I selected them. I had some eligible individuals and I said, okay, I'm going to select this and this not. So when we lose this, if this was not selected in a random way, then we have to move to these quasi-experimental models. So now we would be ready for the next session, and in the next session we're going to talk about these models. I already explained why the random selection is important, when can I use it, why can I use it, what can be included in this, and okay, let's say now that this was not random. And that's why these are known as quasi-experimental models. And with econometric methods, I am going to try to have a counterfactual in an artificial way. And I think that this is what we can analyze in the next session. We're going to solve a question that I am just checking right now. How can you find an homogeneous counterfactual in a treatment, for instance? I think that this is a very important question, and if this is experimental, then we need to design this in this way, and because otherwise this is going to be complicated. And I am going to solve this question in the next 2 sessions. I really hope that this answered your question, Milton. And if not, we can talk about this in the next session, or you can also. I am going to answer your question in the next session. So thank you very, very much for your patience and for your attention. And I'll see you on the next session. Have a great day.
No.